And the next question, 2-ethyl and 3-phenyl oxyrane. What is it? Oxyrane, ethylene oxide or ethylene epoxide. This is called oxyrane. But on this carbon and on this carbon there are substituents. So the starting material is 2-ethyl. So here is the ethyl group that is placed, CH2, CH3, and 3-phenyl. Say this is the phenyl group, and the oxide, ethylene oxide, cyclic ether. So this is the starting material, 2-ethyl. So this is the second carbon, third carbon, 2-ethyl, 3-phenyl oxyrane. And this is subjected to what? A Grignard's reagent, C2H5MgBr. ET stands for ethyl, ethyl magnesium bromide, in the presence of ether, Et2O, solvent, and on heating. This is the one. So how is that this Grignard's reagent where the ethyl carbanion R minus, this is the one where the reaction goes by SN2 mechanism, and thereby whenever Grignard's reagent is added R minus, here we are adding ethyl magnesium bromide. Therefore this C2H5 minus part will attack, as it is going by SN2 mechanism, less hindered and less substituted. Carbon atom will be attacked by this R minus, in other words ethyl carbanion, and the product formed is then subjected to hydrolysis. What is the final product? And the final product is mentioned with the IUPAC names. So thereby let us see what will be the product of the reaction. Here is the ethyl group, here is the phenyl group we have. So thereby this C2H5O minus will attack the carbon where phenyl group is there, and hence this will shift here. So that the moment C2H5 minus attacks here, this will be cleaved, CO bond, and ring is opened, as there is a lot of ring strain, as it is a 3-membered ring. And this O minus which is formed in the next step during the hydrolysis in the presence of an acid, alcohol is formed. So thereby the product of the reaction is an alcohol. But which alcohol is formed? So therefore we have, when this O becomes OH, here is the C2H5 and this is the third carbon on which OH is there, and then this is the with phenyl group. So on the third carbon we will have OH, on the fourth carbon we have phenol, and these two carbons. So total 1, 2, 3, and this is the OH, this is the 4, 5, 6. So a hexanol will be formed, but the OH group is on third, fourth group is phenyl. So 3-ethyl 4-phenyl hexantriol. No, 4-phenyl hexantriol. So therefore 4-phenyl hexantriol, A bit is the right answer. So let us check now the complete reaction. So as we could see, the starting material is a substituted oxyrane. So therefore this is ethylene oxide, and here is the ethyl group that is attached, and here is the phenyl group that is attached. And now when we are treating with the Grignard's reagent ethyl magnesium bromide in solvent ether, then this ethyl group, as we could see, will migrate, and then the ring is opened. So this C2H5 minus will attack here, and the ring is opened. O minus is formed. That O minus will be attacking MgBr. So thereby we get this ethyl group remains same, this phenyl group remains same, and this is becoming OMgBr. And here what do we have? That ethyl group is attacking. This is the CH3CH2 ethyl group. So this reaction is going by SN2 mechanism. Therefore this ethyl carbanion will attack this less hindered carbon than ethyl group being present in the next position. And this, an acidification, as you know, this becomes OH. So therefore this ethyl group here, and this is the OH as it is, this is the phenyl group, and this is the, once again, what we have is ethyl group. And thus we are getting the alcohol. So now we have OH group is here. So if we start from here, 1, 2, 3, 4, 5, and this carbon is 6. So it is hexane 3 all. But on the fourth carbon we have phenyl. So 4-phenyl-hexane-triol. That's how an alcohol is formed. So the answer is A.